So this is very haphazard, but I thought I may as well take advantage of the fact that we had no one presenting this week and just talk about something I was running over the last fortnight because I could, and that I think would be useful for the community, but I don't know exactly what to do with it. And none of this is polished. Most of the analysis was done yesterday, a little bit the day before. So there will be ACCESS labels missing. There'll be stuff that I don't explain. Please just stop me and ask questions. So there's more of a stimulus for discussion than any kind of polished presentation. So I've, over the last couple of years, done some analysis of the decadal hindcast CMIT runs, so the DCPPs, which is starting from observations every November. They run an ensemble of models for 10 years. And so the idea is that you can use these to forecast, this is actually a better picture, from that point into the future, and you can see how long you have predictability in the system given initial conditions. But all of these things are typically run with historical forcing, so they're trying to predict observations. And so they start with this massive drift, whereas the model shifts from observational happy place into the model's happy place. And then they've got climate change on top of them. So if you're looking for very small amounts of predictability from initial conditions, that gets really tangled up in the climate change signal. And I've had so many things I've tried to explore where I get this phantom predictability out to 10 years. So you get lots of predictability for the first 3 or 4, and then you get almost nothing, but it won't quite go away because the things that are initialized at different times have slightly different climate change forcing. And so things that are initialized in 2010 end up warmer than things that are initialized in 1980, even though you wouldn't expect the initial conditions from those two to matter in some scenarios. So climate change has always bugged me in a science sense because I can't do statistics on this predictability limits because there's this extra climate change signal. And so I was cycling home a couple of weeks before the end of the quarter, and I realized that with the amount of spare compute we had, it would be possible to replicate these things using the pre-industrial conditions and pre-industrial control. So this big black line is a pre-industrial control. And then I've run perturbations every 5 years, just 10 ensemble members, like 10 to the -4 degree perturbations, and run them and see how long they stay together or not. So that's the first one I ran, where the black line's the pre-industrial control and the 4 colored lines are ensemble members. And this is Nino 3-4. Sorry for the paleo people, call me out on stuff if I haven't explained it properly. But so this is some index that we might care about trying to predict. Right. And then the 4 ensemble members follow the black line pretty closely for the first year. So you have predictability for the first year. And then by the end of this run, at I think it's 6 years, then there's not much coherence between the ensemble members and you've lost that predictability from the initial condition. These are the runs I've managed to get done over that fortnight. Every time something died, I just abandoned it and moved on the basis that I could tidy it up later, and I was trying to get as much run as quickly as possible. So I have daily 3D ocean temperature for the first year of most of these runs. I tried to run out to 6 years, but some runs didn't make it past the first year. There's a handful that only made it to 5 years. So there is data. I have done some stats on this, but it's not fully complete. I would like to go through and fill out the gaps in this table. So ideally this box would be entirely beige, that I'd have daily output for 10 ensemble members for all of the restarts, and I would have monthly output out to 6 years for all of the restarts and all of the ensemble members. Couple of results. So this is looking at the spread of Nino 3-4 across the ensemble. So what's the standard deviation between ensemble members? So at the very start, when we 0 months lead time, there's minimal standard deviation. All the ensemble members are clustered together really tightly. And then you hit 12 months and they're a bit more spread out, but not as spread out as you get by the time you hit 5 or 6 years. And so I then took the climatology out of the standard deviation, which seems statistically dubious, but I'm going to go with it for the moment, just so we get this clean line here. And eyeballing that suggests that at 0 years, everything is really tightly clustered together. And then after 12 years, by eye, you could say that's still, things are still tightly clustered together. Dave, are you talking?
Oh, sorry, I was mouthing 12 months rather than 12 years. Sorry, I didn't mean to distract you.
Yep, okay, 12 months, not 12 years. Seems like a valid point. 24 months, maybe, and 36 months, you'd say is definitely the same as the end. So it looks like our Niño 3-4 predictability limit in ACCESS ESM 1.5 is going to be somewhere between 1.5 years and 2.5 years. So you can do that by real statistics as opposed to using eyeballing. And I think I get pretty much the same answer, whatever method I use. But this is a test of how much the Niño 3-4 values within an ensemble are clustered together versus the difference between the different initializations. And so your p-values are off the scale small for the first year. And then same as we saw when we're eyeballing the standard deviation on the previous plot, somewhere between the first and second year, you pretty much run out of predictability. Maybe we wanted to call this particular dip back into peak as 0.05 predictable, but I'm not really convinced. And then there's nothing else after that. So that's without the climate change signal in this model, there's an upper bound on ENSO predictability that's pretty much 2 years. So that's cool. Good to say that. I have no idea how to interpret this one, but it seemed interesting. So I was just looking at how does predictability link to the initial conditions? Are there certain initial conditions where the models or the like individual runs cluster together way more tightly than other runs? And in the literature, people say that if you start from a large El Nino, that produces much more predictable conditions than starting from neutral or starting from La Nina, because we have this predictable jump from El Nino into La Nina, and that's the opposite of what I'm finding. So I don't know if this is statistically significant. I don't know if it's ACCESS being funny or something about the initialization with observations that most people are doing. But it seems like when you initialize in these La Nina states, then you get tighter ensemble spread and more predictability than if you initialize in a positive anomaly, so an El Nino state, in which case there's a lot more spread after 12 months. Same thing for any time less than 12 months. After you get past 24 months, then it goes away because that's the point where we have no predictability. So that's odd. Possibly another lead that I'd be interested in looking into. Third thing I looked at was just, can we use this to say what causes any one particular event? So one of these initializations starts pretty close to no anomaly, and then one of the ensemble members gets an El Nino relatively strong after 12 months. And so then I've just picked out that ensemble member in red compared to the average of the others in black on this side of the screen. And so while most of them have not much anomaly, this one swings into a strong El Nino and then crashes down into La Nina, and then kind of bubbles along after that. So then I looked at the daily data, just seeing how quickly it spreads out. And so they start almost, there is no difference between the average of the other ones and this one El Nino member. And then if you run forwards for 10 days, you start to see some differences in the winds. And if you run forwards for another 10 days, then the winds are really different. And we're starting to see sea surface temperature anomalies. And then at some point after only a couple of months, that particular member is showing a much stronger sea surface temperature pattern in the equatorial Pacific than the rest of those ensemble members. And I feel like there should be something interesting we can do with this to try and work out the mechanisms, but I'm not sure what to go from there. I guess one thing it does show really clearly is that the atmosphere becomes very different very quickly, and the ocean is much slower to create noise and to spread out.
Jemma,
Yeah. Yep.
On that side, can I ask a question or two?
Go for it.
So I think I kind of missed it.
Careful.
So the wind anomalies, are they relative to the ensemble means?
Yes.
Yeah. So I kind of, when you're looking at the zonal winds or whatever, I would have thought all the stuff that's kind of extratropical would get very noisy very quick. So regardless of what ensemble member you look at, I think you're going to find lots of similar stuff happening in those upper two panels.
Agreed. Can you think of any way to remove noise that's not relevant?
Well, I think what you want to do is just focus on the equatorial zone. Because that's probably where your differences are going to come about. And then you'll have a very different color scale highlighting things that are different. So you think about like westerly wind bursts or MJO events or that kind of thing.
Yeah, I guess what I was really hoping to see was whether we could say if it comes from the extratropics or the tropics. But I don't think we can do that with this type of plot with the amount of noise going on there. Yeah,
just because the like, I don't know, I could be wrong. I just think if you pick up any individual member, even that don't lead to a big El Nino event, they're going to have a lot of differences in those extratropical regions. You might be able to track it back after you find something in the equatorial region and then kind of trace it to an extratropical system if you know specifically what you're looking for. That's just my thoughts.
Yep, I like that. Yeah, that's my very haphazard summary of some stuff I did and looked at. Very happy to take questions, and I would be very keen to know if anyone else wants to use this data or could imagine using it for something as I go through and tidy it up and work out what variables to save and what variables not to save to free up space again.